I would like to ask you all a question. What did you do to get ready this morning? Now, all of us probably did the same normal hygiene routine, took a shower, brushed our teeth, but we also made a decision. We went to our closet, we looked through our clothes, and we decided what we were going to wear. And we change our appearance all the time. But what if we could change more about ourselves? What if we could change aspects of ourselves on a genetic level? What if we could even change our eye color as easy as we change our clothes? Well, that brings me to what I want to talk about today, and it's CRISPR. It stands for Clustered Regularly Interspaced Short Palindromic Repeats. And I have to be honest with you, that was the single hardest part of this speech, was memorizing that acronym. So, what is CRISPR? Well, in a word, it's revolutionary. It's the ability and the technology to precisely edit DNA and change a living organism, change the genetic makeup of an organism. It has tremendous medical applications. It has the potential to cure disease, correct genetic defects, and even alter human evolution as we know it. So I would like to start by saying that I'm no expert, I'm no biologist, but I'm going to use the work of some very intelligent people to help me explain this. And I found this subject incredibly fascinating, and I want to share what I've learned with you today. So we're going to talk about the history, the application, and also the problems that are faced with this new technology. And so to start, let's talk about the origin of CRISPR. Dr. Lander and Cell explains that it took many different scientists a very long time to come up with this technology. In fact, it took over 20 years from the start of the research to where we are today. And Heidi Ledford in Nature says that while there were many people that were involved in the development, two people stood out, and that's Dr. Doudna and Dr. Champartier. They discovered a protein called Cas9, and this Cas9 protein is really the key to the technology that as we know it. So how does it work? Well, to put it very, very, very simply, this Cas9 protein selects a portion of DNA, cuts it, and then inserts a new piece, thereby changing the genetic makeup. So what can we use this for? What are some of the applications? Well, there's many different applications, and specifically the medical applications are incredibly profound. As Dr. Kim and Koo of the Seoul National University tell us, that CRISPR has the potential to cure diseases such as HIV, cancer, even genetic defects such as muscular dystrophy. And think about this for a moment. I think it's safe to say that we all know somebody that has suffered from cancer or perhaps muscular dystrophy. And we know how terrible those diseases can be. But think about the treatments for some of these diseases. Some of them are even worse than the diseases themselves. Think for a moment if there was a way to completely cure a disease quickly, easily, and cheaply. This is the significance of this technology. It has the power to do these things. And there's other applications that are a little more interesting. So, like we talked at the outset, because we're able to change and edit an adult's DNA in real time, we might be able to have cosmetic applications like changing our eye color. And perhaps even more interestingly is something called designer children. And that's where scientists are able to alter the DNA of an embryo and allow parents to make choices on what sex their child is, their appearance, their height, even their level of intelligence. And now we might be thinking, I don't know if I like the idea of my parents being able to decide what I look like. But there's something more important in this, and that scientists potentially will be able to eliminate a lot of the genetic defects that many children are born with. So what's the catch? Why aren't we doing this now? Well, like with any new technology, there are problems associated with it. And with CRISPR, it comes down to two. And one is our understanding of the genome. We don't have a firm enough grasp of what the consequences will be when we make changes to our genetic code. And next is just simple human error. We can probably all relate when writing a term paper or an essay that there's typos. Now, imagine for a moment if you were working on your DNA. Think how significant even a small mistake would make on your body. So a lot of these applications, these exciting applications, may be far off into the future. So, in conclusion, CRISPR is an exciting, revolutionary new technology that has the potential to cure diseases such as cancer, to correct genetic defects, even may allow us to design our own children. And CRISPR has been the culmination of a lot of work by a lot of people. But like with any new technology, it does have its problems. And it comes down to our understanding of the genome and also just our capacity for human error. But it may be possible in the future for you to go down to your local pharmacy and get a shot to cure your cancer. Or you may be able to go to your closet and take a pill to match the clothes that you're going to wear. Yes, in the future, it may be possible to change your eye color as easily as changing your clothes. Thank you.